So, getting into observations of Atlantic storms or hurricanes, we have seen an increase in the power and frequency of these storms. And this has been something that we're also seeing in the Eastern Pacific. And we've also seen a decrease in strong storms in certain locations of the world. And so we might even be seeing an alteration in where energy is condensing itself in various locations. Because, like I said, everything's getting shifted and changed. And so what we think of as what it used to be is not what we can expect for the future. As far as hurricanes and global warming, extreme heat in the air or the ocean is a form of energy, and the storms are derived from that energy, and so we can expect an increase in strength of storm. As far as what the records are showing, the average number of North Atlantic storms that are hitting the coastal Atlantic seems to increase. But as I mentioned, there has been a bit of a decrease in the frequency of storms hitting the Asia Pacific regions. With that said, when they do hit over there, they are incredibly strong. So these are very, very strong storms. There are some things that the records are showing because, like I said, I want to go through the data. And while the number of storms seems to look like it's increasing in the Atlantic Ocean, that could just be the act of better satellite data. So I don't want to say that frequency has increased, but I want to say definitively with global climate change, we have seen an increase in the strength of the storm itself. Because, like I said, we might just be better at recording storms. As far as looking at how we used to record storms, so getting into this frequency number argument, ship log and landfall, we are still doing it today, but you can see when radio observations began to come into effect, and then we have aircraft observations coming into effect. So when we started recording storms here, and then radar tracking come into effect, right? Here, and then satellite tracking come into effect here. As far as size of storm, now one of the information things that we saw in the module 11 when we went through the topic was that radius image of how big was various recent storms, and they had Katrina, Ike, and Sandy, and you saw that they got progressively bigger, and that's actually true for hurricanes overall. All tropical cyclones seem to have gotten wider. They are bigger than they've ever been. These suckers are 800 miles across. These are huge storms. We used to record storms, so in the 50s and 60s, and it was something between 300 to 500 miles across if it was a huge catastrophic storm. 300 to 500 miles across. Katrina was about 460 to 480 miles across, right? So it still fell in that. Sandy was over 800 miles across. This thing was a ginormous wide storm. So these storms are not just strong, but they have a lot of width, right? They're going to cover a lot of area when they make landfall. So that is something that we can also say is a global climate impact, because with more heat capacity allows for the making of a larger storm. If I can make a larger storm, that storm can be bigger, right? Which gets into that heat capacity. Here is a graphic of heat storage capacity within the ocean and the ocean surface waters, and you can see that the ocean surface water has greater heat storage capacity, as well as it is heating up more so than it ever has. And this is only a small set of years. This is 2003 to 2008 on its clip-it, but you can see the average heat capacity has increased in just that short snippet of time in that 5-year interval. Storms are going to continue to strengthen, and they're going to be big. It's just the new normal. As far as hurricane intensity and sea surface, there is a direct correlation between the temperature of the sea surface and the strength of the storm. The warmer the ocean surface, the stronger the storms tend to be that season. And so here is your correlation lines to show you that correlation. And then this is that graphic again of how big these suckers are. Once again, these lines are radius. They're not the full circumference, or not circumference, the full diameter. Sorry, wrong wording. Diameter is circle. I know my geometry. So in conclusion, extreme weather does not prove the existence of global warming, but climate change is likely to exaggerate it by messing with the ocean currents, providing extra heat to form tornadoes, bolster heat waves, lengthen droughts, and cause more precipitation and flooding. The key is extreme weather is a consequence of climate change, not a cause. So what can we expect for us up in this New York region? Well, we can expect our seasons to actually be rainier. So while the rest of the United States is drying out, we actually are going to be pretty wet here. That wet, however, is going to be kind of altered, and it will be sort of seasonal. We're getting more into sort of rainy seasons and dry seasons. And so we're going to see drier summers and wetter falls and springs. And when it does rain, it will be more severe. As far as storms go, we can expect stronger storms. About the same number of storms, but when they hit, they're going to be a doozy, right? So that's what we're going to expect. Another thing that I already mentioned, but we can actually expect more of, is sort of that dichotomy of extremism where I'll see kind of drought and wet seasons. So we'll see them kind of spread out. So I could go like a week without any rain, and then all of a sudden it'll rain and it'll rain heavy. And another thing that we're going to see more of is extreme weather fluctuation within seasons. So those seasonal averages will no longer be plain line. I will get these anomaly days, and these anomaly days will occur more often. So like in winter, I will go from having a bunch of days that are what I would consider normal winter weather, and then all of a sudden I'll get like an 85-degree day, which is absolutely ridiculous. And then it'll go back down. And while that has happened throughout history, they are becoming more frequent. So within 1 month, I'll get like 4 anomaly days or 6 anomaly days. And that's very strange. That's not what it used to be. We used to get like 1 anomaly day a season, not a month, an entire season. So 3 months in the year. And so that's another thing that I'll expect is more of these really strange anomaly days where all of a sudden I'll get like this blip in what the norm should be for my climate averages. And so there you go. That's our new future. There's a little bit on global warming's link, global climate change, global warming, and its link to weather events. But weather events don't prove global warming, global climate change. Measurements of how we are feeding into the greenhouse gas material in the atmosphere and how that is holding the heat in the lower parts of the troposphere of our atmosphere is how we are determining the actual global warming, global climate change. That's how we base that. What we're talking about here with extreme weather is how is this increase and change in the atmospheric composition going to change what we consider our normal climate regimes? How is this going to alter what is normal conditions? As always, if you have any questions, comments, concerns, please post in discussion.